Hello students, this lesson is about mid-segments of triangles, and we're going to use mid-segments, use the properties of them. So first of all, what is a mid-segment? Well, a mid-segment is a segment that connects the midpoints of two sides of a triangle. So here you can see that R is the mid-segment of side X, is the midpoint of side XY. And the reason I know that R is the midpoint is because the section on this side, XR, has been marked equal to the section on this side, RY. And so therefore I know that R is in the middle of that side. And likewise, T is in the middle of side XZ, and I know it's in the middle because this piece on this side, XT, has been marked equal to the piece on this side, TZ. So that means that the piece that connects R and T is called a midsegment. It is right between, or it connects the midpoints. Okay, so now whenever we have a mid-segment, there are two things that are true about it. First of all, a mid-segment, like the mid-segment in this picture, TR, is always parallel to one of the sides of the triangle. So we have that YZ is parallel to RT. So these two sides are parallel. And the second thing that's always true about mid-segments is that the length of this mid-segment is always half of the length of the side that it's parallel to. So whatever the measurement for ZY is, TR is half of that. So if this line down here was 10, then this line would be 5. Or if TR was 8, then the line down here is 16. So the one in the middle is half of the one on the sides. So first of all, or now that we know that, can we prove that PQ is a mid-segment of this triangle? In order for it to be a mid-segment, two things have to be true. PQ has to be parallel to DE, and PQ has to be half as long as DE. So let's show each of those to be true. First of all, let's show that they're parallel by finding the slope. Parallel lines should have the same slope. So if I use my slope formula here for the points P and Q, letting Q be x1, y1, and P x2, y2. Okay, when I plug into my slope formula, I find the slope for that line is 1. Okay. Also, when I plug my slope in for DE, and I do 2 minus 0, 5 minus 3, I'm also going to find that the slope of this line is 1. So since these two lines have the same slope, they are parallel. And then the second thing I'd like to show is that PQ is half as long as DE. To show that it's half as long, I'm going to have to use the distance formula. So I'm going to use a distance formula on PQ to find out how long it is. So the distance formula is the one with the big square root. Okay, I'm going to plug into the distance formula 3 minus 2 squared plus 2 minus 1 squared. Okay, and when I do that, I'm going to get square root of 2, which is 1.41 approximately. All right, so now we're going to find the length of the line DE and see how that compares. Well, when I plug the points for D and E into the distance formula, I get 2 minus 0 squared plus 5 minus 3 squared, the square root of that, and I get square root of 8. And the square root of 8 is 2.82. So you can see that 2.82 is twice as big as 1.41. So the mid-segment times 2 is equal to the side, or the mid-segment is half as long as the side. Okay, let's see if we can apply what we were just saying about half as long to find JK and AB. Okay, first of all, JK here. In order to find out what JK is equal to, we're going to have to find the piece that JK is parallel to. Well, JK, I've highlighted it here with the light green, is parallel to the bottom piece here, AC. And since we know that AC is 10 long, the midsegment is half as long, so this must be 5 long. Now let's find AB. Okay, so AB of the side on the outside, we're going to have to find the piece that this is parallel to. So AB on the outside is parallel to LK on the inside. And since LK is 6, well then AB must be 12. So in conclusion, we have JK is 5 and LB and AB is 12. All right. Which segment in the picture is parallel to XY? Okay, so XY right here, what segment is parallel to it? Well, it looks like that's going to be on the inside here, T or UT is parallel to XY. Okay, and apparently the answer is not coming up, but you can go ahead and write down or just mark in your notes there. The answer for that is UT is parallel to XY. Then is ST parallel to YZ? Do you think that ST is parallel to YZ, this piece on the side here? Well, the answer is that yes, that's parallel. Now, how do I know that that's parallel for sure? Because S is the midpoint of this side between the X and the Y, and T is the midpoint between X and Z on this side. So because ST is a mid-segment, I can know that it's parallel to the side. Yes, they are parallel because ST is a mid-segment of the triangle. Okay, and let's see if we can find YZ. Well, YZ, we just said it's parallel to ST, so it must be twice as long, so that must be 8. And then XY must be 10 because it is twice, XY must be 10 because it is twice UT. All right, and now can we find the perimeter? So, let's see if we can find the perimeter of this triangle. XY is 2. Okay, now if XY is 2, and we know, and it gives us up here that at X, Y, and Z are all midpoints. So if X is a midpoint, and I know this piece is 2, then this entire side length here must be 4, okay? Because I know that the AX on this side is 2, so the whole piece must be 4. XY is 3. Okay, XY is a mid-segment on the inside. So so it looks like XY here is going to be parallel to AC. So since those two are parallel, if the one inside here is 3, then the one out here must be 6. And they're telling us that BC is 9, so go ahead and put 9 in the diagram. Now to find the perimeter, we simply add up all the sides, 4 plus 6 plus 9, and we get 19 for the perimeter of the triangle. And last example, and this is really what we're going to focus on in class. These particular problems have a little bit of algebra in them. Given that DE equals x plus 2 and BC equals half of x plus 19, find DE. So first of all, go ahead and label the things that they give us in the picture. They tell us that DE is x plus 2, and they tell us that BC is half of x plus 19. Now, from the picture we can see that DE is a mid-segment. Now, the reason I know it's a mid-segment is because the piece on this side, BD, is marked equal to AD, which means that D is the midpoint. And on the other side, I see that E is the middle because AE is marked equal to EC, so E is a midpoint. So this segment DE is a mid-segment. Now, since it's a mid-segment, we can know that the piece in the middle here is half as long as the piece on the edge. Or, I like to say, half of the long side equals the mid-segment. So what we're going to do is we're going to say that twice DE, 2 times this DE in here, is going to equal BC. So we're going to write a formula saying 2 times DE equals BC. So plugging into that formula, we're going to have 2 times x plus 2 equals 1/2 x plus 19. And then we're going to go ahead and distribute. That will give us 2x plus 4 equals half of x plus 19. And subtract 1/2 x to the other side. 2x minus 1/2 is 1.5x plus 4 equals 19. Subtract 4 to the other side, we get 1.5 equals 15, and then divide both sides by 1.5, and x is 10. So now that we know x is 10, we can find DE, because DE is x plus 2. So that would be 10 plus 2, so DE is 12. And that, my students, is what we will be doing with mid-segments. Great.